Okay, digging into our second section with exponents and scientific notation. All right, so the key here is understanding what exponents mean, right? So exponents are used for repeated multiplication, right? So we look at our base, right? That is the number that is being repeated, and then the exponent tells us how many times. So this is 2, 2, 2, 3 times, and again it is repeated multiplication. So 2 times 2 times 2 is 8. So 2 to the third is 8. Okay? Now, when exponents are negative, that tells you that the base is on, I like to say, the wrong side of the fraction line, right? Every number, right? Every real number is either rational or irrational, right? Meaning it could be written as a fraction or not as a fraction. Well, 2 to the negative third is a fraction, right? It's 2 to the negative 3 over 1, all right? Since this is negative, that means it just needs to be put on the bottom, right? So on the bottom of my fraction, I now have 2, and since it gets flipped to the bottom, it becomes positive. That's how you fix that negative. All right, now nothing's on the top, right? So if nothing's on the top, it's automatically a 1, right? And then we still have our times 1 on the bottom that was already there, right? So what this really is, we know 2 to the third from above. We know 2 to the third is really 8, so this is just 1 over 8. There it is. All right, 0 as an exponent. Doesn't matter what it is, it automatically turns it to 1. Anything to the 0 exponent turns it to a 1. All right, and this is just then combining a few things, right? I see that this x is negative, so I want to move it. I see that this z is negative, I want to move it. The y is perfectly positive, so it's fine. So on the top, I get my y to the third stays up there. In order to make the x positive, I got to put him on the bottom. In order to make the z positive, I got to put him up top. And there it is. Okay? We then use our product, power, and quotient rules, right? So the product rule says when you have repeated multiplication of the same bases, that means we can add our exponents. So 6 plus 4 minus 1, that should be 9, right? So that means we can combine our bases since they are all the same, right? Since all of our bases are x, we can combine all of our bases to a single one and add the exponents so we get x to the 9. Right? We have a power being raised to another power, right? 5y to the 5th to the 6th, which means we take our power shower, right? Which means we then multiply our exponent. 6 times 5 is 30, so this just becomes y to the 30th. All right, our quotient. Right, our quotient says, again, if your bases are the same and it's division, if it's division, we can subtract the two numbers. Now again, there's two ways to do it. I always just do the bigger minus the smaller, right? So the bigger number here is 7. Oopsies. Bigger number here is 7. The smaller number is 5. So I subtract 7 and 5 and I get 2. All right, so now the question then becomes, does this x to the second go on top or bottom? And we just look, where is the bigger number? Is the bigger number on top or bottom? It's on bottom, so that means our x to the second will be on bottom. All right, on top, right, since there's nothing else up there, that's just a 1 again. Okay, and then we have another problem combining all of that. Another two problems combining all of that. Okay. Last but not least, we have our scientific notation, right? Again, just knowing our scientific notation, 4.2 times 10 to the 4th. So what that means is I need to take my decimal place and move it over 4 spots. So I'm left with 4, 1, 2, 3 zeros then. Right? So I get 42,000. An easy way to check that is, right, that means our decimal's at the end. If we were to bring it back 1, 2, 3, 4 spaces, that would then give us our 4.2. All right. Same thing with the -6, right? E, right? If we have an E, it means the same thing. This is the same thing as me saying 5.21 times 10 to the 5th. Same exact thing. All right, now going backwards. All right, I have a big number and I want to simplify it with scientific notation, right? So we would add our decimal, and this is going to be 5.2. All right, and the question is now, how many decimals did I just create? All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 5.2 e to the 9th, you can say, or 5.2 times 10 to the 9th, right? I move that decimal, right? The decimal's over here. I'm going to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9 spots to create 5.2. All right? Same thing for number 15.